What if I told you that engineers once built a passenger plane so massive it could carry over 850 people, yet despite being a technological masterpiece, it became one of aviation's most expensive failures? Welcome to the World Documentaries, where today we explore the bittersweet story of the Airbus A380, the largest passenger aircraft ever constructed. This engineering marvel stands as tall as a 7-story building and challenged everything we thought we knew about the future of air travel. Before we dive into this remarkable journey of ambition, innovation, and hard lessons learned, please subscribe to the World Documentaries and hit that notification bell. Give this video a thumbs up if you're ready to discover how European engineers dared to challenge Boeing's dominance with a $25 billion gamble that would ultimately reshape aviation in ways nobody expected. The bold vision, challenging Boeing's empire in 1988, at the headquarters of Airbus in Toulouse, France, a bold vision was taking shape. Jean Pierson, Airbus's president, nicknamed the Bear of the Pyrenees for his fierce determination, set his sights on an audacious goal: to dethrone Boeing's legendary 747, the undisputed queen of the skies. At that time, Airbus controlled merely 15% of the global aircraft market, while Boeing commanded nearly 2/3 of all commercial plane production. The 747 had revolutionized air travel since 1970, making international flights accessible to millions and generating enormous profits for Boeing through its unique jumbo jet monopoly. Pierson believed the future belonged to even larger aircraft flying between major hub airports, carrying 25% more passengers than Boeing's flagship. The stakes were astronomical, with development costs that would eventually reach $25 billion, money that Airbus would never fully recover, making this one of the most expensive bets in aviation history. The design challenge creating the impossible when Jürgen Thomas was appointed to lead what would become the A380 project in 1996. His team worked in secrecy inside an abandoned office building with minimal resources. The engineers joked that the windows did unopened to prevent them from committing suicide during moments of despair. Yet their motivation never wavered. Their first major breakthrough came with a revolutionary design choice, creating a fully double-deck configuration using an ovoid-shaped fuselage rather than the traditional circular cross-section. This innovative oval design would allow to full-width passenger decks, enabling the aircraft to carry up to 193 more passengers than the 747 while maintaining optimal fuel efficiency. However, the team faced a critical challenge: weight. Every time you increase an aircraft's size, its weight increases exponentially, threatening to make the plane too heavy to fly efficiently. The solution came through a groundbreaking material called glaire, a composite of glass fiber and aluminum that reduced weight by 30% while maintaining exceptional strength. Engineering marvels, wings and wake turbulence. The A380's wings would become some of the most technologically advanced ever produced, with a surface area of nearly 850 square meters, 54% larger than the 747's wings. These massive wings weren't just about size. They featured complex flaps and slats that aerodynamics experts consider the finest wing design in aviation history. Yet their enormous dimensions created an unexpected danger: wake turbulence so powerful it could potentially rip roofs off buildings or send smaller aircraft spiraling out of control. To solve this life-threatening problem, engineers conducted extensive tests at a state-of-the-art aeronautical laboratory in Lafargue, France. Using laser-lit smoke curtains, they made the invisible turbulence visible, studying how air vortices formed at the wingtips. The solution was elegant: wingtip fences that prevented high and low-pressure airstreams from colliding. This innovation ensured the Super Jumbo's wake turbulence would be no greater than the standard 747's, making the skies safe for all aircraft. The logistical nightmare, building across Europe. When Charles Champion took charge of bringing the A380 from design to reality, he faced an unprecedented logistical challenge. The aircraft would be built simultaneously in 4 countries: wings in the United Kingdom, fuselage sections in Germany and northern France, and the tail in Spain, all requiring transport to the final assembly plant in Toulouse. Even Airbus's massive Beluga transport plane, specifically designed to carry aircraft components, proved too small for the A380's gigantic parts. Champion devised an extraordinary solution: a complex convoy system involving ships, barges, and specially modified trucks. The fuselage sections traveled over 5,000 kilometers through narrow European villages, literally touching house walls as they squeezed through streets designed centuries before anyone imagined such colossal cargo. In the tiny village of Lavignac, residents watched in amazement as airplane parts nearly as wide as their streets crept past their homes, representing one of the most ambitious transportation operations in civilian engineering history. Crisis point. When cultures collided by 2006, disaster struck the A380 program when engineers discovered a catastrophic error during final assembly. The wiring systems, with over 500 kilometers of cables per aircraft, didn't fit. Thousands of wires were too short. The problem stemmed from a clash of cultures. French and German teams had insisted on using different computer design programs that could communicate with each other. This seemingly small oversight had devastating consequences, requiring complete dismantling and rewiring of aircraft already under construction. The delays cost Airbus a staggering $2 billion and pushed deliveries back by up to 2.5 years. Major customers like FedEx and UPS cancelled their cargo version orders, costing another $5.1 billion in lost revenue. The entire A380 program teetered on the brink of collapse. With critics questioning whether the Super Jumbo would ever enter service, management worked frantically to retain passenger airline customers, and miraculously, not a single airline cancelled their orders during this crisis, testament to their faith in the aircraft's revolutionary potential, triumph, and terror, from first flight to emergency. When the A380 finally took its maiden flight on April 27, 2005, 40,000 spectators gathered around Toulouse's airport fences to witness history. The massive aircraft, weighing 600 tons at takeoff, 40% more than a 747, lifted gracefully into cloudless skies, performing flawlessly during its 4-hour test flight. Over the next 19 months, the plane underwent 2,500 hours of rigorous testing, from scorching hot climates to freezing conditions, pushing every system to its absolute limits. Then came the ultimate validation on October 25, 2007, when Singapore Airlines operated the first commercial A380 flight to tremendous fanfare. However, 3 years later, on November 4, 2010, disaster nearly struck when Qantas Flight 32's Rolls-Royce engine exploded shortly after takeoff from Singapore with 469 people aboard. Captain Richard de Crespigny faced catastrophic damage. Half the aircraft's systems failed, including hydraulics, brakes, and flight controls. His masterful handling and the A380's robust design saved every passenger, proving the Super Jumbo's incredible resilience under the most extreme conditions imaginable. The unexpected ending: when giants fall. Despite its technological brilliance and initial success, the A380 faced a harsh reality. The aviation industry was changing faster than anyone anticipated. While Airbus bet on hub-and-spoke travel with massive planes flying between major airports, airlines were instead embracing fuel-efficient twin-engine aircraft like the Boeing 787 and Airbus's own A350. These smaller, more economical planes could fly directly between cities, bypassing congested hubs, entirely exactly what Boeing had predicted back in 1997 when they abandoned their Super Jumbo plans. In February 2019, Airbus made a heartbreaking announcement. A380 production would end in 2021 after building just 251 aircraft, far short of the 1,000 units needed to break even on the $25 billion development cost. The final A380 was delivered to Emirates in December 2021, closing a remarkable chapter in aviation history. By 2024, only 189 A380s remained in service, with just 10 airlines, and 5 carriers had already retired their entire fleets. The magnificent giant that was meant to dominate the skies for decades had become a commercial failure, teaching the industry that bigger isn't always better. The story of the Airbus A380 is not simply a tale of failure, it's a profound reminder that even the most brilliant engineering QAUnt overcome market forces and changing customer needs. From Gene Pearson's audacious dream to the engineers who solved seemingly impossible problems, this aircraft represents human determination and innovation at its finest. While it never achieved commercial success, the A380 proved that European cooperation could create something truly extraordinary, pushing the boundaries of aerospace engineering and inspiring future generations. What lessons do you take from the A380's journey? Should companies bet big on revolutionary technology, or focus on incremental improvements that meet market demands? Share your thoughts in the comments below. We'd love to hear your perspective on this remarkable aircraft's rise and fall. Do you not forget to subscribe to the World Documentaries and turn on notifications to explore more incredible stories of human achievement, ambitious failures, and the bold visionaries who changed our world. Hit that like button if you enjoyed this honest look at aviation history, and join us next time as we continue exploring the extraordinary stories that shape our understanding of innovation and risk.